Now, in order to determine the ratio of acid to base, we need to apply the Henderson-Hasselbalch equation. We can write it in two different forms, and it doesn't matter which way we write it. The outcome should always be the same. We can write it as pH equals pKa minus log to the base of 10 of the acid concentration over the base concentration. We can, of course, also write it the other way round. So we can write it as pH equals pKa plus the logarithm to the base of 10 of the base over the acid concentration. Either way is absolutely correct and will give us the same result. Now, what we are looking for is actually this ratio here, this ratio that we are interested in. So what we do is we just do a little bit of rearranging of the equation. So, for example, we bring this, the log, to that side, we bring the pH to the other side, and we end up with log of acid concentration divided by the base concentration equals pKa minus pH. And we can then take both sides 10 to the power of, so what do we get? We get 10 to the power of log acid over base concentration. So these are our concentrations here, equals 10 to the power of pKa minus pH. Now we know that 10 to the power and log 10 cancel each other out, so we get on the left hand side the ratio of acid concentration divided by the base concentration, and on the right hand side of the equation we have 10 to the power of pKa, which was 6.45 minus 6.58. So that gives us 10 to the power of negative 0.13. We need to calculate that first, of course. Bitmers. And that gives us a ratio of, we can do that quickly. We need to calculate 10 to the power of negative 0.13. So that gives us 0.741. So that gives us 0.741. So our ratio of acid to base equals 0.741. We can also write this as 0.741 over 1. This means we need 0.741 parts of acid and 1 part of base. This is basically what this expression tells us. And we just simply divide by 1, because divided by 1 is always the same thing. We can also write this in a slightly nicer form if we just simply expand this fraction here, both parts by 100. So we can say this gives us 74.1 parts of acid and 100 parts of base. And that makes it just a little bit nicer to read and to understand what this base acid or acid-base ratio actually means.